guys. All right, so here we go. Now, focus, people, because I think most of this is review, so let's try to get it done so you have some time, of course, to get working on your homework. I'm assuming this looks familiar to you. This is what we're going to be using today. We're going to start working on trigonometric ratios, comparing two sides on a triangle. We're also going to talk special triangles, your 30, 60, 90, 45, 45, 90. So you might need a refresher on that. I'm going to show you, of course, how to type angle measurement, sine of an angle, into your calculator today. We're going to be conscientious about our mode, and then applications. You know I love my word problems. We're going to have a couple word problems today, too. All right, all sorts of good stuff that I know that you know. But let's just review, you know, the love of math. Remember on your right triangle, we're in right triangles. Your hypotenuse is your longest side across from the right angle. Then, your other sides. You're going to have an acute angle labeled. They're using this bottom left one. Of course, the side straight across, opposite. The side next to it we classify as adjacent, next to adjacent. Now, our trig ratios. You, I'm sure, are phenomenal with sine, cos, and tan. I'm going to back it up. Sine. What two sides does sine compare? Opposite over hypotenuse. So I'm just going to fill that in. I'm going to abbreviate. Okay, cosine. What two sides does cosine compare? Adjacent, hypotenuse. And then tan, of course, TOA, are opposite over adjacent. Now, I don't know if you've seen these other three on the right side. Those might be brand new to you. I don't know how much they cover those. I know we don't in regular geometry. I don't know if you get into them in honor geometry. CSC, that stands for cosecant, is how you say that, cosecant. SEC, secant. And then COT is cotangent. These are the reciprocals of our main three trig functions. I put them in a specific order on here for this reason. Cosecant is the reciprocal of sine. So you just flip sine. So cosecant is hypotenuse over opposite. Okay. Secant is the reciprocal to cosine. So it's going to be hypotenuse over adjacent. And then cotan, reciprocal of tan, adjacent over opposite. So really when it asks you for all six, there's only six, these six trigonometric functions, I always work in the main three. I find sine, cos, tan first, and then it's just a matter of flipping them around. It's not that big of a deal. But those three on the right side might be new to you. All right, here we go. Find all six trigonometric ratios. All right, let's start with the main three, sine, cos, and tan. So sine, of course, opposite, which opposite of our angle theta 2, over the hypotenuse 3. So right away, I'm going to go ahead and list cosecant because it's just going to be the flip of that, 3 over 2. Easy enough. 2 out of 6 done. Okay, cos. So now I need adjacent. So adjacent to my angle is that square root of 5 over hypotenuse 3. I'm going to go ahead and list secant. Now, I'm kind of like, oh, secant. Because when I do the reciprocal of it, I'm like, Yahtzee, you've got a radical in the denominator. Okay, so we got to rationalize it. So I'm going to put my square root of 5 on, which, hey, is good review. Thinking about the final exam, rationalizing came up in chapter 1. Can't help myself. So I'm going to have 3 square roots of 5 over 5. And then let's go ahead and do tan and cotan. Okay, tan. So I would say that's the one maybe obnoxious part today is you do have to do a little rationalizing sometimes. So TOA, opposite, adjacent. And I'm already kind of groaning. Because yes, I know it needs to be rationalized, but you know, work smarter, not harder. I am going to back up and rationalize that in a sec, but I'm like, ooh, you know what? I'm going to flip it first for my cotan. Because then I don't have to do any simplifying on cotan. Cotan's ready to rock, of course. Tan needs my root 5. So 2 square roots of 5 over 5. Now, if you were to, of course, do the reciprocal of 2 square roots of 5 over 5, you'll get the same thing. It just takes more simplifying, and nobody wants to deal with that. Okay. So any questions on finding all 6? That's really as bad as it gets. Or we might really live on the edge and they give you two sides and you have to find the third one. Ooh, okay, if cos theta equals 3/4, sketch a right triangle, acute angle theta, find the other side. Okay, make yourself a right triangle, however you want to make your right triangle. I'm going to label, doesn't matter, top or bottom, one of the acute angles theta. I don't know because I'm standing here, we're going to do the bottom one. Now, they give you cosine is 3/4. So you know two sides on the triangle. Remember, cosine is adjacent over hypotenuse. So I know adjacent to theta, 3. You know the hypotenuse, 4. Now, in order for me to do all of the trig functions, I'm going to need this missing side. What fine theorem from geometry are you going to use to find the third side? The Pythagorean theorem. I'm just going to call it A for right now. A squared plus B squared equals C squared. And remember, you always equal your hypotenuse squared. A little throwback to geo. Can't help myself. 3 squared is 9. 4 squared is 16. Let's subtract 9 off, so you're at 7 over there. And I'm going to root it. Now, think about our final exam. Technically, you have how many answers? 2, plus or minus square root of 7. However, I'm only using which one of those? The positive, because we're talking about the side length of a triangle. Okay, so, still going, okay. All we've done is got the third side. I need, because they gave you cosine, I need the other 5 remaining trig functions. Well, they gave you cosine. I'm going to do it out of order from the last one because I'm going to just cheat a little bit and do secant right away so I can just flip it. That's easy enough. So then I'm going to do sine and cosecant. So sine, of course, opposite, square root of 7, hypotenuse 4. Let's go ahead and do cosecant, the reciprocal of sine. And we've rationalized enough by now, you know it, 4 square roots of 7 over 7. We got it. And then last but not least, let's do tan and cotan. So TOA, opposite of theta, root 7, adjacent 3. Cotan, do the reciprocal. And of course, we are going to have to rationalize it, but we can do that in our heads probably by now. 3 square roots of 7 over 7. Got it. Okay. So, realistically, you might have needed a refresher, but have I taught you anything new thus far today? Sure haven't. That's why you got to love it. All right. Now, we are going to start using, and it's going to be used a lot, our special right triangles, our 30, 60, 90, and our 45, 45, 90. So I thought you might need a little refresher on how the sides and the proportions and all that good stuff work. I'm going to start with a 30, 60, 90. Okay. So just to kind of talk about how the sides work, you know, this is the important part. Now I'm going to try not to be too dramatic, well, a little dramatic, probably can't help myself. So across from the smallest angle, 30, is our smallest side. So if you remember, we call that the short leg. And then across from 60, our medium angles, our medium side, the long leg. And then obviously we all know what the hypotenuse is. Okay. So if you know the short side, because everything kind of hinges from the short side, I'm just going to call it x. To get the long side, you multiply the short by a square root of 3. So if you had 10, you'd have 10 square roots of 3. And to get your hypotenuse, you double the short side. So those are your ratios or proportions that your triangles work on. So if my short's 10, 10 root 3, 20, bam. And of course, you can convert between the two. So hopefully that looks a little familiar to you. Let's do a 45, 45, 90. I think this one's a little easier, actually. Now, here's the nice thing about your 45, 45, 90. You know, I can't. That scared me, but I don't know, maybe anyway. Okay. You know, I can't control my love of geometry. 2 congruent angles, 45, 45, means you have 2 congruent sides. That is the base angle theorem converse. It was right on the tip of our tongues, right? Base angle theorem converse. Okay, so nice thing, your sides are always congruent. They're going to be the same. I'm just going to label them x and x. And then to get your hypotenuse, it's your side, one of your congruent sides, times the square root of 2. So that is how those ratios are going to work, because we're going to start seeing some 30, 60, 90, 45, 45, 90. Hopefully that comes back to you just a little bit. And you can see I threw them on here in a nice pretty picture versus my hand-drawn stuff. Now, don't get crazy on this chart on me yet, okay? We're going to start using these. You do not have to have it memorized at any point, okay? We're going to start using these, though, coming up in some of the subsequent sections. So I just want to throw it on there for you. I haven't even talked about how to do a 0-degree angle yet. We will. But you're going to start seeing like your 30 or 60, what they're in radians, and the ratios of your sides. Do you have to memorize those sides? No, you sure don't. But these values, as you look through here, are going to start coming up a whole bunch. Now, if I want to do a trig ratio for another angle, like a 47-degree angle, I want the sine to 47 degrees. I mean, I can't make you a special triangle with a 47. So I'm going to show you how to do those on your calculator. So we got all sorts of good stuff. So tan of 40, I'm going to have to do it on my calculator. So pull up your calculator. Now, before I start typing on my calculator, I'm already like, oh, crud. My mode is in radians. These angles are degrees. So I'm going to switch my mode into degrees. Yours is not in degrees. Make sure you switch it. Okay. So tan of 40, pretty easy to type in. Tan 40, nothing magical here. Does it say what to round to? No? Okay, so I'm just going to make something else. Let's go 3. I'm going to put 0.839 for that. Cos of 20. Nothing magical there. Cos of 20. Let's round to 0.940. Let's go with. And now we have a little problema. Do you have a cotan or a cosecant button? No. So you can still do it. Get ready. So cotangent is the same as 1 divided by tan. Now, I'm not going to go on a spree here and talk about y for every single one, but remember, tangent is your opposite over adjacent sides on your triangle. If you, of course, multiply by the reciprocal, you end up with cotan out of it. So how I can punch this in my calculator, I can do 1 over tan. Cosecant, I can do 1 over sine. And I'm going to type those in for you in just a second. Sheet of paper, that's all you have to do for right now. Okay, so I'm going to use my identities. 1 divided by tan of 14. So 4.01, that's all I've got in me today. And hopefully you already did your 1 over sine of 80. So 1.015. Okay. Any questions on our calculator?
Oh, would you say that this paper is more like cardboard or more like paper?
It's not cardboard.
It's cardstock.
Exactly.
So it's in the middle, Owen. It's in the middle. We're going to go with that.
Like these are.
All right, so back to our right triangles. Now, I feel like I'm teaching geometry today. I love it. Focus, people, focus. So they're going to ask you to start solving the triangle. Well, think about a triangle. There's 3 angles in it and 3 sides. So when we start talking about solving triangles, I want to know 3 angles and 3 sides. So that means, notice it says determine all 5 parts. Because you know the right angle. They're going to give you the 90-degree angle. You're going to have one little piece of the puzzle. You want to make sure you know all sides, all angles. So when it says to solve a triangle, I need everything. So solve a triangle. I'm like, yes, I can rock star this one. Because this is one of our special triangles. I don't have to do a lot of work. It's our 30, 60, 90. Clearly angle B is 60. I mean, you can get fancy if you want to write it out. I'm just going to label the picture. Now, they gave you the hypotenuse. We have to know our ratios on a 30, 60, 90. I'm going to get the short side next. I know to go from the short to the hypotenuse, it's double. I'm going the opposite way. I'm not going to double it. I'm going to cut it in half. So what's half of 12? 6. And then I can get the long side, because I know it's the short one with a square root of Square root of
3.
3. Okay, double check it. Do you know all the angles, all the sides of that triangle? Yes, I've got it all. Crushed it. We're on to the next one. Okay. Now, we're going to start having some applications of these triangles, and we're going to have some things which aren't 30, 60, 90, 45, 45, 90, so we're going to get into all of that. So they're going to have some word problems, some application problems today, and they're going to talk about angles of elevation, angles of depression. So get ready for my drawing skills. It's going to be amazing. Now, elevation. Elevation is from your line of sight, this very lovely lady, looking up. So usually you're talking about looking to the top of a building, to the top of a cliff, something like that. Angle of depression is you're looking down. So now she's looking at this poor little person that's fell on the sidewalk. I don't know what happened there, but anyway. So angle of depression is from your line of sight looking down. Now I might even throw in, here we go, geometry, alternate interior angles. Does that ring a bell? I love the reactions. What do you know about alternate interior angles? They're congruent. Okay, here we go. All right. Oh, it's going to be good. A giant redwood tree. Let's draw a tree.
What?
No judgment on my drawing skills. I can't be good at everything, kids. Okay. Cast a shadow, 532 feet long. Now, remember, we're in a right triangle section. This is going to boil down to a right triangle. Redwood tree. Where does your shadow end up? On the ground. So here's my shadow, which is 532 feet long. Now, the shadow, you could have put the shadow on either side. I just put it on the left side because, I don't know, I'm standing on the left side of it. Whatever. You can see your right triangle happening. All right, find the height of the tree. So I want to know how tall the tree is. If the angle of elevation of the sun, so looking up, angle of elevation is the bottom looking up, is 25.7 degrees. Okay. Now, no special angle there. I can't use, my 30, 60, 90 stuff. I'm going to have to go old school and use my SOHCAHTOA. So I'm looking at my sides. From the 25.7, I've got opposite and I know adjacent. So I'm going to use tan. So tan of 25.7 equals my opposite side over adjacent. I can't write 532. 532. There we go. 32. Got it. Now, from here, you probably don't need to write anything more. To go to your calculator, I know you guys know to get rid of that 532, you're just going to multiply. So punch that in your calculator. It didn't say what to round to. Surprise me, I guess, on how tall the tree is. 256 you should get. I'm going to label 2 feet. I know that's a pretty impressive picture of the tree. Owen likes it. Any questions on that one? Because there's more drawing to come. Yes. Okay. From a point on the ground, 500 feet from the base of a building. All right, let's draw my building. I'll put some windows in it. Here's a door. That's as good as it's gonna get. You don't have to be as artistic as I am. All right, let's keep reading here. From a point on the ground 500 feet from the base of the building. Now again, it doesn't matter which side of the building you're on, just because simply I'm standing here on the left of it, I'm gonna put it on the left of it. 500 feet from the base. An observer finds the angle of elevation to the top of the building. So here's my little observer. Nice, isn't it? My stick figure, it's really nice. Okay, to the top of the building. So you can see your right triangle happening here. And I gotta reread it here for the 24 degrees. Okay, all right, I see you. I got, okay. Angle of elevation of a flagpole. Oh yeah, flagpole atop the building. I I don't know which way the flag should be blowing. I don't know. That might not be drawn to scale. We're gonna work with it though. So the angle of elevation to that's 27. So you have two right triangles happening in here. You've got my blue one, and then you can see I did my red dashed one. And this angle, of course, bigger, that's the 27. Okay, it's getting crazy here. Find the height of the building and the length of the flagpole. Well, okay. Well, over. So height of the building, so that's my blue side. I'm just gonna call it H for height. I know that was magical. And then we need that flagpole, X. Okay, so first, two right triangles in the picture. So probably, most likely, I'm feeling two equations. Next, let's think about what trig ratio we're gonna use. I'm thinking we're on tangent again because we're doing opposite of those angles, and you know you have that common adjacent side of 500. So I'm going to start with the blue triangle. So I'm going to start with the 24. So I'm going to set that up. If I do tan of 24, I would have H, the opposite side, over 500. Well, that seems easy enough. Okay, got it. So I can find the height of the building. I'm just going to times by 500 and punch it in. All right, so what do we have for the height of our building? Round to whatever, I don't care. What do you get?
222.6 feet.
All right, I'm going whole number.
210. What?
I'm going whole number. Just to mess with Avery. You're welcome. Okay. And my advice on rounding, kind of my rule of thumb, and you know I'm not picky about rounding, I just follow the problem. I saw everything in the problem, all the numbers, the numerical values were whole numbers, so I'm going to go to the whole number. Now, red triangle. Let's take a look at what we can do with tangent on the red triangle, which that has the bigger angle, the 27. Now, the opposite side of the red triangle is the top all the way to the bottom. So it's the flagpole plus the building. There is a key, plus. So my flagpole plus the building height, which we just found. And then, of course, my adjacent side is still the 500. So not too bad of a setup. You just have a little bit more work, obviously, because you're going to do your 500 to cancel out your denominator. And you have the lovely extra step then of subtracting the 223 off. Big deal. All right, so let's see what we got for the height of our flagpole. Round to whatever, I'll take whatever. 32 we should have. Got it. So the math is easy, setting up the picture is the key. Any questions on the picture? Now, clearly, I'm getting carried away with the word problems, not just my love of word problems, but what do people struggle with the most? Word problems. Nobody messes up SOHCAHTOA or Pythagorean theorem, okay? Let's do one more. Oh, God, a hot air balloon. This is going to be I'm going to go for it on this picture. Get ready for it, kids. I'm going to draw the little basket. It's going to be something. Hot air balloons floating above a straight road. To assume their height above the ground, the balloonists, it's fun, simultaneously measure the angle of depression, looking down, to two consecutive mileposts on the road on the same side of the balloon. The angles of depression to be found are 20 degrees and then 22 degrees. Okay, are we ready for this? So, I'm going to draw my road. Nice, I know, it's really nice. I'm going to draw my hot air balloon. It's floating above the road. Okay, all right. So here's my little basket. It could be better, it could be worse. Don't judge my hot air balloon, okay? And it's above the road, wherever here. I just threw it up at the top. Elliot.
Would the triangle go to the top of it?
Well, hang on, I'm working on it, Elliot. I'm working on it. Okay. To estimate their height above the ground, okay? So remember, height always makes a right angle. So straight down, that's going to be easy to do. The balloonists simultaneously measure the angle of depression to two consecutive mileposts on the road. Okay, so I'm going to fill in, I'm going to probably kind of extend this a little bit in green. So the height, of course, to the balloon, here's my right angle. So you can see your right triangles happening here. Now you've got your two mileposts, two consecutive mileposts on the same side of the balloon. So we've got our mileposts on the road here in the row, consecutive. I don't care where here's my one post. I'm not going to draw a post. Nobody wants to see that. Here's my second post, let's say. Okay, now, get ready. Now, angle of depression, you're looking down. Now, with a horizontal. So we're in here in our little hot air balloon. I'm going to draw a little parallel to my road, parallel, horizontal, because remember I threw out alternate interior angles, that's coming at us. And it says, of course, balloon has 79 angles of depression. One of them is 20 degrees, and then the other one is 22 degrees. So I'm going to let this guy be my 20 degrees. So this angle would be congruent to this one, because they're alternate interior angles. Or, okay, let's just get serious here. Is the angle of depression always going to be congruent to the angle of elevation? Will that always happen? You're always going to end up with the parallel lines of the alternate interior angle. So just FYI. Okay. So we've got that filled in. Then you've got your other, let's do it in red, your other angle to your other milepost here, made with the horizontal. Now, you can see clearly that angle's the bigger one. That's your 22 degrees, which again is congruent to this one, because I have alternate interior angles. I know this is like the most complicated of all pictures you will have. This would be, are you ready for my pro hint? Like a good bonus type of problem. All right, carrying on, moving on. So you can see we've got these couple different things here. Let's see what else we have. So angles of depression, I got it. How high is the balloon? So I'm after this side, the height. So I'm going to go ahead and label that. And of course, here's the other thing. We do kind of, I'm like looking at this, or I'm reading this. I'm like, I clearly want to use tangent like the last ones. I'm like adjacent. Hey, I do actually know part of this adjacent side. One of the key thing here, mileposts. How far apart, not drawn to scale, are your posts here? 1 mile. Not drawn to scale, right? Okay, so I'm thinking about tangent. We've got our two angles. I've got the blue and I've got the red. So I'm really going to end up writing two equations. One's with the blue angle, one with my red angle. I picked up blue because I don't know why. I'm going to start with blue. So I'm going to do tan of 20. Got it? Got it? Opposite would be our height. Adjacent. Interesting. So we've got the 1 mile between it. I have no idea how long this is. I'm just going to call this side x, this piece of it x. So my whole adjacent side is the 1 plus x. Now I'm just going to let that sit there for a second. I know I have multiple variables in it. I know it's a hot mess. I'm just going to let it sit for a minute. I'm going to try to set up another equation with my red 22 using tan again. Opposite h, adjacent x. I can't write in the top, h over x. Okay, here's where it gets good. You have a system.
Oh my God.
I love the reaction. We've got a system of equations. I'm going to try to use a little bit of substitution. I wish you could see the looks on some of your faces right now. It is super priceless and I love it all. So here we go. So first, I don't like either equation. It's a lot of fractions, obviously. So I'm going to clear the fractions on both of them. So I'm going to times this guy by x. So I'm thinking about my red one. I'm going to put it as x tan of 22 equals h. Okay, all right. The blue one, I'm going to do the same thing. I'm going to clear the denominator. I just don't like the fractions in it because these look messy. Okay, and I'm going to think of my blue one then. I'm going to sneak it underneath. 1 plus x tan of 20 equals h. And you're like, we're still not getting anywhere, right? I haven't solved for anything. But wait. They both equal h. So it's really like I'm going to use substitution, and I'm going to substitute this expression in for h. Or, of course, the other one in. It doesn't matter. We're really going to set them equal because I feel like I'm getting to the bottom of the screen. Let me scroll it up here a sec. So I'm going to kind of have my starting equal here, x tan of 22, my red, equaling my blue. My 1 plus x tan 20. Got it. Now we just have the fun-filled job of solving this. Now, as always, work smarter, not harder. At first, I'm like, oh, God, I got to distribute this tan of 20. I'm like, no, I don't feel like doing that. Let's get rid of tan of 20. I don't want to distribute. Distributing is not getting you anywhere. Okay, so I've got 1 plus x left over there. That's not so bad. I'm going to pull up my calculator because I don't know what tan of 22 over tan of 20 is. Tan 22 divided by tan of 20. Let's just leave it 1.11. Let's make it easy, right? So don't forget your x. Got it. Let's go back to full set. Okay, we can solve this for x, piece of cake. I'm going to subtract my 1x off. I put the 1 on for dramatic emphasis. So I'm at 0.11, x equals 1. Divide that up. What's 1 divided by 0.11? I feel like I'm at the bottom again, so I'm just going to scroll it up. All right, what do you got for x? X equals 9.09, 9.1. I don't care, whatever you want to round to. I heard Owen's first, so I'm going with that. Now, are we done?
Yes.
No, because the final answer was the height of the balloon. So I'm going to back substitute, because it's right here. I'm going to use this one. The height is x times the tan of 22. You know what x is. So I'm going to have 9.09 times the tan of 22 degrees will give you the height. God, I love it. What is your final height of that balloon? What do you got? 3.6. 7. Label. Miles. What a great problem, people. Let's just recap how wonderful it was, because I'm really proud of this one. This is such a good one. Good bonus type one. So you've got your angles of depression. I had a system of equations. I had to use substitution. And then I had to back substitute in to get my final answers. I don't know what more you could want in a math problem. I'm pretty proud of that one. Round of applause for me. Okay, any questions on that one I can answer? All right, so of course,